Enertronics' advanced solar power technologies came from Virginia Tech Future Energy Electronics Center, aka FEEC, Blacksburg, Virginia. Team FEEC, led by Dr. Lai, was the top 3 winner of the Google Little Box Challenge in 2016 for solar inverter design competition, in which there were more than 2,000 teams from worldwide industries and academia, including companies such as General Electric and Group Schneider, and FEEC was the only academia and the only US team listed as a winner. Holding in Dr. Lai's hand is the little box that won the competition. It is a 2-kilowatt solar inverter, weighs just about 3 pounds with 98.2% overall efficiency, and a 400-watt paralleled power optimizer prototype with 99% efficiency. The key to such a little box technology is the wide bandgap semiconductor devices. Here we have 3 solar inverters. The left-hand side is a 5-kilowatt transformer isolated inverter. The top right-hand side one is a 5-kilowatt non-transformer isolated inverter. The 2-kilowatt little box solar inverter developed by FEEC, a recently developed 400-watt microinverter, weighs only 3 ounces. Such a size and weight reduction is achieved by the use of gallium nitride transistors for megahertz switching, which cuts the size of magnetic components and capacitors dramatically. The sensors are calibrated precisely to ensure the optimizer tracks maximum power point effectively. Experimental results indicate that our paralleled power optimizer can achieve 99.8% MPPT efficiency. To meet the National Electric Code (NEC) requirement on arc detection and rapid shutdown, we developed an advanced signal processing technique for rapid shutdown. The arc detection test setup is based on the UL 1699B standard, and the signal is processed with our 100 MHz digital signal processor that also controls the entire power optimizer. Test results indicate that detection can be done in less than 0.5 seconds. To understand what a power optimizer is, let's start with a series-type power optimizer, which only performs maximum power point tracking with a non-isolated low-voltage output. So it requires multiple units in series to obtain sufficient output voltage. The newly developed parallel power optimizer can independently produce sufficient 400-volt output for downstream inverter connection. Since the output voltage is fixed, the inverter can be designed without oversized devices and components. The cost saving for the entire system can be explained with these 2 figures. On the left-hand side, without power optimizer, the inverter needs to be designed for a wide input voltage range due to the effect of clouds and shadings. The voltage range of an inverter corresponds to its cost due to high voltage and high current component requirements. With our power optimizer and a fixed voltage inverter, the total system cost can be cut to 37.5 cents per watt because the inverter doesn't need to be over-designed. The paralleled power optimizer output is high voltage, low current. A smaller copper wire can be used to save cable cost compared to low voltage, high current cases. By miniaturization and integrating the power optimizer into the PV panel, we can further achieve additional 25% to 50% balance of system cost reduction. Enertronics CEO, Mr. Don Collins, indicated that the market was growing at 12% compound annual growth rate. The market size will reach $4.4 billion in 2031. Our share is projected to be 45%, or $2 billion in 2031. Mr. Don Collins also pointed out that the global PV market reached 627 GW, and among that, more than 65% are utility-scale installation. Similar to the saving in string inverters, Enertronics Parallel Power Optimizer, PPO, allows the use of center inverter to be 1x rated, as compared to 2 to 3x rated inverter in a conventional system. In addition, the inverter can be transformerless for further cost saving and efficiency improvement. Under DOE ARPA-E contract DEAR00000904, the FEEC is developing a single-source inverter for utility-scale PV applications using a cascaded multi-level inverter circuit that takes 400-volt input and directly converts it to a 13.2 kilovolt for a 3-phase 100-kilowatt PV system. The design provides a 30 kilovolt isolation barrier that allows elimination of a bulky, unreliable high-voltage transformer. A 12-module single-phase stacking prototype has been tested to 33.3 kilowatt. The waveforms indicate that with 12 modules cascaded in stack, the voltage waveform resembles sinusoidal. The total harmonic distortion, THD, is 5.7%, even without filtering.